Okay, so what I want to do here is go through the SSA triangles one more time, having no solution, one solution, or two solutions, because I didn't give you any problems to practice with. So what you can do is you can look at this video to try to either practice on your own, or if you didn't understand it from the last video, these are more examples, so hopefully you can understand it after I go through it one more time. And hopefully I'll explain it better, showing you why it's ambiguous here. So remember, law of sines can be used to solve either when you have two angles and a side, or when you have side-side angle. Now, if you have either angle, angle, side, or angle, side, angle, this is not ambiguous. You will always have one solution, because look, if I have angle, angle, side, or angle, side, angle, because the triangle's angles add up to 180, you will already know the third angle. There's no ambiguous case here. However, if you have side-side angle, then you have possibilities of having no solution, one solution, or two solution. So let me go through these problems, 25, 29, and 31 on page 543. If you kind of understand the last lesson, you could try it out yourself and check your work, or you can just watch me work through the problems. So number 25, I have A is equal to 3, B is equal to 2, and A is 50 degrees. So the way the book has it, angle A is across side A, so that's our first ratio, sine of 50 over 3 is equal to sine of B over 2. Because now if we have lowercase b, we could find uppercase b, because that's the second ratio we're going to write. So we cross multiply here and I get 2, or actually I could just multiply both sides by 2, and I get 2 sine 50 over 3 is equal to sine b. And remember, to find b, we're going to inverse sine both sides. So b is equal to the inverse sine of 2 sine 50 over 3. So we just go ahead and put that in our calculator. The inverse sine, remember, make sure your calculator's in degree mode. And then so what we do is we do the inverse sine of 2 sine 50 divided by 3 and we get our angle here is 30.7 degrees. So angle B is 30.7 degrees. Now, here's how to check for for if it's one solution, two solution, or three solutions. First of all, it's not no solution because I have an angle here. So it's either one solution or two solutions. Now here's how I check what it is. So remember, on your unit circle, there are two places where the sign can be 30.7. Right here, and also in quadrant 2, let me try to draw it. It has the same y value here, right? Now this is 30.7. How do I find what this angle is? Well, 180 minus 30.7 will give me this angle. So I do 180 minus 30.7, and that gives me 149.3. And that's this angle here. So you have two possible angles. You could have an angle of 30.7, or you could have an angle of 149.3. 0.3. Now, the way to check if you have two solutions or not is to check your original problem. A equals 50. Well, if A equals 50 and B is 149.3, 149.3 plus 50 is 199.3. And that is over 180. So we're not able to have a triangle there. So this one doesn't work. This is our angle B. Okay? And there's only going to be one solution here. So if angle B is 30.7, then I know angle C, I just add 50 plus 30.7 is 80.7. And then I just subtract that from 180 because the angles of a triangle add up to 180. And so I think that should give me like 99.3 or something. There we go. 99.3 degrees. That is angle C. And then once you have angle C, now you can use the law of sines again to find your side C. So I'm just going to start doing the sine of 50 over 3 is equal to the sine of 99.3 over little c. And then now I could cross multiply here. And so c sine 50 is equal to 3 sine 99.3. Divide both sides by sine 50. And then that will give you letter C. So I get C is 3.86. Okay, so we found everything that we needed. We found what capital B was. And then from that, we checked if it was going to be one solution or two solutions. We found it was one solution because it doesn't work with 149.3. And then we just used the fact that the angles add up to 180 to get C is 99.3. And we use the law of sines again to find side C. Okay. Now I'm going to do 29. Now 29, A is 4, B is 5, and A is 60 degrees. Sorry about that. Okay, so I have capital A, lowercase a, so I know I could do sine of 60 over 4 is equal to sine of B over 5. Now if I multiply both sides by 5 to get sine B by itself, I get 5 sine 60 over 4 is equal to sine B. And then now if you look at this, I know that B is equal to the inverse sine of 5 sine 60 over 4. If you do that on the calculator, you do inverse sine of 5 sine 60 divided by 4. Whoops, make sure you answer it like that. And you get an error, which means there is no solution. Okay, so here there is no solution. And you could actually tell by looking at this thing, because 5 divided by 4 is a number bigger than 1. Sine 60 is root 3 over 2, which is also, it's less than 1. So this is still going to be bigger than 1, and you can't, the inverse sign has to be from -1 to 1. But if you don't catch that right away, you could just put it into your calculator and you'll see that there's no solution. Okay, so now let me do 31. And 31 will be a 2-solution problem, as you might have guessed. But now I'm going to show you how this works again. Okay, so 31, B is 4. C is 6. And B is 20. Okay, so here I have capital B, lowercase b, so I could do sine 20 over 4 is equal to sine of capital C over 6. I multiply everything by 6, so I have 6 sine 20 over 4 is equal to sine C. I inverse sine both sides, so C is equal to the inverse sine of 6 sine 20 over 4. If you do that on the calculator, so here I'll do it for you here. 6 sine 20, close those parentheses, divided by 4. It gives you 30.9. So capital C is around 30.9 degrees. Now remember, there are 2 places that can have that sign. So if I look on a unit circle again, remember, something is at 30.9 degrees. It will also have the same y value over here. How do I find that? Well, I just do 180 minus 30.9. And that gives me 149.1. Okay, now I'm going to check with my original problem, and capital B is 20. So now, obviously it works with 30.9, but does it work with 149.1? 149.1 plus 20 is 169.1, which is still it's still under 180. So that means we could have a third angle there. So that's how you could tell I have 2 solutions. This is obviously going to work. And then this one, 149.1, still works with an angle of 20. So when that happens, we have to do 2 separate calculations. We have to do one where C is about 30.9, and then we have to do another one where C is around 149.1. Okay? Now, if that's her second angle, you could find the third angle missing. If capital B is 20, capital C is this, then we should be able to find capital A, because all I do, these add up to 180. So 30.9 plus 20 is 50.9, and 180 minus 50.9 is 129.1. So A is approximately 129.1. In this case, if C is 149.1 and B is 20 degrees, 149.1 plus 20 is 169.1. And then so 180 minus 169.1 is about 10.9 degrees, is 10.9 degrees. So A is approximately 10.9 degrees. Okay? So we found so here are our 2 solutions. Okay? So we can have where C is 30.9 and A is 129.1, or we can have C is 149.1 and A is 10.9. In each of these cases, we still have to find little a. That's the one thing that we're missing. So we're going to use the law of sines here again. So sine B, or sine 20 over 4 is equal to the sine of 129.1 over little a. We just cross multiply and we get a sine 20 is equal to 4 sine 129.1. Divide both sides by sine 20. And we get a is equal to 9.08. And then if we do it here, we get sine 20 over 4 is equal to sine of 10.9 over a. So we get a sine 20. A sine 20 is equal to 4 sine 10.9. Then divide both sides by sine 20. And so a is, in this case, 2.21. And those are our two solutions. Okay? So once again, you find the angle that we need, and remember that there are two places it can happen. Once we find the two places, you have to check, does the second one work with the angle given to us? And in this case it did, so we create two separate solutions.